Big class today.
So, we're going to revisit observability today. I think that this is one of those things that, thank you. It's one of those things that I'm not sure that people fully appreciate why it's important.
Again.
And there's a danger with observability as well, and I will mention that. Basically, what you're doing, pretty much anything you do in the cloud, is creating what you'll sit down and just say, well, technically what I want to do is I want to collect information. How are people accessing my website? Where did they come from? What keeps them there? And then somebody's going to come along and they're going to say, this is a gold mine. Because now we know what they're doing. We know where they came from. We know what their interests are. We know how to get them to engage. And we're going to turn those into exactly the things that we need in order to improve our product's market penetration, which is a polite way of saying we can extract more money out of them. And that's a recurring theme here. But I'm going to focus on this from the more technical side today, but I will touch on the other side as well. As soon as I put the mouse on the right screen. Go over here, click, come back over here so you can't see it. There we go. All right, so one of the things that can get really hard as you start finding, how many of you have put observability into your capstone project? How many of you debug it? That's in essence the question. So that's what we're going to be talking about. What do you put in it? How are you going to debug your product? What's the information you need? And what are you going to do when somebody calls? Because now you're actually successful and the product stops working at 3 in the morning. Because it's always 3 in the morning somewhere in the world. That's the weird part about the cloud. You think that what you're doing is local, but then before you know it, you've got 500 customers and they're scattered all over the planet. And they expect 24/7. All right, so what is the 3 a.m. test? Your app breaks at 3 in the morning. You get the page. Can you figure out what happened from the logs without reading source code, without reproducing it, or asking anyone? And that's really your ideal. You want to go, you want to look at your information, you want to be able to say, I see what I think the problem is. Enough information so that you can say, let me restart the database. Oh no, it's not the database. Look, it's the RabbitMQ service I set up for streaming events. And that seems to be jammed up, so what's going on there? Or, oh, it looks like my load balancer isn't currently load balancing, it's sending everything to one node. Those are all things that happen in the real world. I'm not sure if anybody noticed, but Amazon had a big meeting recently where effectively they said, okay, we have to stop screwing up with the AI hallucinated stuff. It's very interesting what happens. And they want to get rid of all the developers, but then they find out that the tools that they've given the developers to get rid of all the developers don't always do a good job. And I can tell you from personal experience that part of that is that they know how to do certain things really well, but when what you want them to do doesn't fit what they know how to do, they will turn it into what they know how to do, and you have to fight it the entire way. So what you end up with is something that works, but it doesn't work right because it's using the wrong model, the wrong technique, or the wrong library, or doing something that's incorrect. So if you can pass this 3 a.m. test, if you can literally say, yes, I know what's going on, I know what I think I should do to fix it, then you've got good observability. Now here's the interesting thing about that. The only people who need to understand that observability data are the people who actually need to make the system work when it stops working. It doesn't have to be pretty. It doesn't have to be verbose. It can be extraordinarily compact. I have seen observability systems that run with very, very small data collection, like 4 bytes. Surprising what you can do with 4 bytes. Not all systems are like that. You don't have to keep it that succinct. In that particular case, we were actually collecting data inside the kernel, so that's why we tried to keep it really small. There's a propensity in cloud services to just assume that storage is free, so what we'll just do is we'll log everything. Logging everything can work, but it also has the downside or the disadvantage of noise. So now you have a signal to noise problem. Have any of you ever used a tool that's noisy, like a pretty printer or a format checker, or Git itself sometimes can be really noisy? Put a couple hooks in there. We talked about hooks last time. Put a couple hooks in there. They start running programs and they start spewing things out. One of my favorite tools for this is LaTeX, which if you've never used LaTeX, you haven't lived. So LaTeX is pretty much one of the oldest text typesetting language. Well, it is the oldest text typesetting language in the world because it was invented in the 1970s by a mathematician who was tired of the difficulty of typesetting math textbooks. As you think about it, that doesn't really lend itself well to movable type. In the 1970s, most of the type was actually hand assembled. And then in the 70s and late into the 80s, that's when it started getting replaced with lithography. So literally they would take pictures, of the picture, and then they would make plates from that. And so they would use offset plates. The plates were engraved, photo engraved. And then we got into this newfangled thing called a printer. Not the old ones that used stone tablets. Those were very dusty. The new ones that actually used black particles on white paper and fuse it. And the ability to create documents that way with computers attached to them also meant that it would be really nice if we actually had a way of building these documents. So mathematician, crazy mathematician who's still alive, in fact, and busy writing the Art of Computer Programming Volume 4 or something, D.G., I don't know which one. His name is Donald Knuth. And he gave us at least 2 things that we rely on today that you probably don't think about. One is called HTML. The hypertext markup language is derived from the original phototypesetting language that he wrote, which was called TeX. The LaTeX part came in after Leslie Lamport, who is also a brilliant mathematician type, and gave us a lot of the distributed systems on which the cloud is built, add a macro package on top of TeX. And we still use these tools today because there's really nothing that does a better job of laying out documents in a structured way. But we inherited that. It's a noisy tool. That was the short end of my long story there. It's a noisy tool. It produces tons and tons of information. You know that it's alive because it's spewing on the screen. The problem is, it spews so much information, you can't see what's wrong. That's why I say, in observability, there's this interesting balance between putting useful information there and overwhelming. I mean, I've watched people, they sit there with compilers, for example, and you try to compile a program. Any of you ever tried to compile a program? And you get a bunch of spew about something. One little error, like a missing semicolon, can cause 100 lines of garbage on your screen, and you're like, yeah. And you have to train yourself to look through the garbage. Because the human brain, when it sees that much stuff, it just sees noise. We actually don't see what's there. We have to focus and filter out the noise before we can see it. So think about that when you're building your observability. Think about the fact that you need not just the information, but you need to look at that information easily so you can identify what's wrong. But what does it mean to say what's wrong? It's something that stands outside the norm. It's something unusual. It's an anomaly. All right, so what makes bad observability? Well, you can say, oh, gee, something went wrong. Well, I get those all the time. They annoy me. It's like, a failure occurred. Okay, and how am I supposed to fix a failure occurred? Something went wrong. I've literally seen that on my screen at least 3 times in the last 24 hours. It's useless. Fine, something went wrong. Tell me what went wrong or go fix it. Don't tell me something went wrong and expect that I can do anything about it. So that's not useful. Connection refused isn't terribly useful either. Why was it refused? What does that mean? Null pointer exception is one of my favorite. Anybody know Java? So Java is a language that doesn't have pointers, and the most common exception is the null pointer exception, which gives you this lie that there actually are pointers, they just aren't shown to you. And the funniest part about this is that the null pointer is actually something that as far as I can tell, came from C. Where in C, the null pointer was it was explicitly used to indicate an invalid value, an invalid pointer value. And the way that we implement this in modern operating systems is we just don't map anything at address 0. That's it. It's a virtual memory trick. And I know this because once I was debugging a program on Windows, a systems program on Windows, and something was mapped at 0. I was like, what? Because that would break all of the assumptions. It's kind of one of those weird things. But at any rate, back to compilers. So compilers are very noisy tools. Null pointer exceptions are something that Java gives you, which doesn't really make much sense because it tells you there are no pointers. Started server. Okay, well, great. Timeout. What was the timeout? What was it trying to do? Maybe I could actually get some information that would allow me to go debug the problem. These are not good things to find in your observability logs. They're not actionable. So maybe that's the right way to think about it, is what you want to do is say, what broke, for whom, using what, when did it happen, and as much as we can tell you, why did it happen? The more information you get on the why, the easier it's going to be for you to do that root analysis, to say, aha, I know what's going wrong here. So, when did it happen? What was the event? In this case, an error. This isn't very verbose, but it is kind of a standard JSON sort of format. This was our API service. Look, the endpoint they were accessing was, in fact, API shows. When you get a 400 error, access denied, all the 400 errors are an access problem. It used to be that they'd give you a 401 or a 403, and they stopped doing that because one meant access denied, and the other one meant not found. And if you told someone the access was denied, you in essence admitted it existed. So they decided they would just simply use not found. But fine. Status, 500. Anybody know what 500 errors? All these HTTP codes, they all have standard meanings. 200 is a success. 300 is a redirect. 400 is a security issue. 500 means, sorry, the server's broken. So when you go to a website and it says server return 500, it literally means the server's broken. There's something wrong with it. So I know as soon as I see a status 500, server broken. And then I'm not asking a whole lot there. I'm giving you a really simple map. 200 success, 300 redirect, 400 access, 500 server's dead. Pretty simple. Knowing that will help you understand what's going on when you see those failures. Latency. in milliseconds. So 12,340 milliseconds is how many seconds? Right. It's good to get fast at this math because you'll see things measured in milliseconds all the time. User ID. So now you know who it was. Who was affected by this? Item count. Okay? I'm not exactly sure what that meant, but it meant something to whoever put it in there. Error. Database query timeout after 10,000 milliseconds. So there you go. There's your 12, 34, 10,000. So somebody tried to find something in the database, and the database didn't respond within 10 seconds. That's a long time. That's like forever. In web years, 10 seconds is an eternity. That's a good question, actually. How important do you think it is to respond to people quickly on the internet?
Really important.
Turns out that Amazon measures the latency in the number of dollars in decreased revenue they know that corresponds to increased latency. They literally say when people have to wait very long, they just go someplace else. If you sit there and wait for 12 seconds for a website to respond, what's going to happen? You're going to go do something else. You're going to go play a game, you're going to go to some other website. You basically have lost that opportunity. And this is literally the way that people actually think about it. This is why these kinds of things are really important. And then this is the best part. It actually used the SQL query. It failed. That's the specific information. What was I doing? And for this, I can say, I was looking up something in the shows table for, this corresponds to whoever this user is. And user ID is a bind variable, so it's user ID. So now I've got a nice match there. How many of you know SQL? A little bit. Do you know enough SQL to be able to read that statement? Right. It's pretty simple. When the SQL statements get really complicated, go find a SQL expert. Or just paste it into your favorite LLM, and it will tell you because they are all trained on SQL. Very, very good. Other query languages, not so much. All right. So when we say something bad happened with no real concrete detail, that's a bad example. But when we say what actually happened, where it was, why it happened, that helps. Strings without structure are much harder to parse. Strings with structure, they have labels. They tell us something. If we don't have any context for the operation, it's hard for us to know what to say. When we're looking at something where it tells us the user what was being requested and how long it took, or what the timing characteristic was, that's great. No timestamps. I'm a huge fan of 8601 ISO timestamps with universal coordinated time. In other words, they're not offset at all. They are easy to parse once you get used to them, and they are lexicographically orderable. In other words, they sort correctly. Whereas if you use, let's see, today is Thursday, March 19th, 2026. Try sorting that with April 2026 or February 19th, 2026. Well, February would come before March, so that would be okay. But the point is that April, February before March is correct. April before March wouldn't work. So you don't get lexicographical sorting. You don't get to know the order very easily. So you end up doing a bunch of work. It's not worth doing that. So our basics are, we have logs. It tells us what happened. The events are individually constructed, we have structure to them, and ideally they would be searchable. So a lot of times these things end up in databases. The downside to these logs is often they have a tremendous amount of redundant data. And so one of the other sides of observability is that as you begin collecting this data, you're looking at it as debugging. It's great for debugging. Somebody else is going to look at this and they're going to say, this is a rich source of information about our customer U4821. How can we sell them more? How can we send them the right advertisements so that we can make money from U4821? But I don't even know everything that U4821 did. I need to know the things that are important. So a lot of times what will happen is you'll keep track of everything, and then you will extract information. You know, what pages did they visit? What are their interests? This is how companies literally can figure out that they can literally figure out that a woman is pregnant based upon what she's buying before she knows. And that's not hypothetical, that really happens. They can figure out what you like as well as you can figure it out. And it's because it's a big business for them. So that data has this darker side, but it can be used for marketing. Yeah. Dark, like, I don't know, I guess that's a judgmental sort of thing. The data can be used for the kinds of observability I'm talking about, which is debugging, but it also then can be used to build value-added propositions for your product so that you can get people to buy more things, so you can get them to engage with your product more, and they're both available from this system. Metrics are really important because what you really want to know is what was going on. Now, how many requests were there to the database service? Was this the only one that hung? Because if this is the only request that hung, then we have a different problem than if everybody's requests to the database were hanging. Why might a database hang for more than 10 seconds? How many of you have ever used a database? Ever had it hang for a long period of time?
I think it was like really big, or we ran some like expensive query, something like that.
Long queries can cause interesting issues. One of the sources of problems there is database transactions. That if you get a transaction where you have a deadlock, then you need to wait until the deadlock detection kicks in. That can actually take 10 seconds or longer. And the reason that we have deadlock detection in databases is because you might have written a piece of code that accesses these tables in one order. You wrote a piece of code that accesses them in the opposite order, and you guys are each locking the database in the order in which you access it. And that can trigger, sometimes, a deadlock. And the database community solves that by watching for those kinds of deadlocks. But normally they're timer-based. It can do it through graph analysis, but I've found that that's a lot more expensive to implement, so often they'll just wait until it times out and they'll kill one of them. Or they'll kill both of them. Because they're transactions, you can restart them. Latency percentiles is a really subtle and interesting one. I'm going to touch on that in a minute. But the basic point is, it's not just how long it takes on average, it's how long it takes worst case. Because worst case is often the indicator that something is going wrong. And you also want to look for trends in your metrics, not individual events. Having said that, I will also warn you, the moment you start using metrics to analyze, you run the risk of missing behaviors because the only thing you look at are the metrics. Traces are really useful because they help you reconstruct what the flow of operations were through the system. So you can see, you had a request come in to the API implementation, plug that into the database put something in the cache, and then the response was sent out. Now the next time it comes in, it may go request cache response. It might completely bypass, well, probably go API cache response, because the data is in the cache. Why do we use caches? What is a cache?
It's just like a memory that's like really fast to retrieve from.
Right. It's just, hey, I just did this. Why do I want to do it again? Here, have a cookie. I just did this. Why would I need to do it again? It's not efficient for you to keep doing the same thing over and over again, repetitively, redundantly. And again, and again, and again. And as amazing as it might sound, it happens all the time. Why? Because almost everything we build is stateless. So I don't remember anything from one call to the next. So I make a call to the API. The first thing the API has to go and do is check and make sure I'm authenticated. But I was just making a call before. You just looked it up. You did everything necessary to make sure I was authenticated. So now if I just simply keep a little hash map on the side and say, have I seen this before? And the answer is yes. I'm like, oh, okay, fine. Then everything is good. I've validated your credentials. And this happens over and over again. When you use a web browser, your web browser does the same thing. It actually loads potentially 1,000, 2,000 different things to build a web page. And it keeps them locally on the drive so that you don't have to download them from the internet again. So caches are a very real part of the system. And as you start trying to optimize any kind of cloud service, you will end up using caches. Redux is a very common thing to use as a cache. Caches are supposed to be read-only. They're an optimization. They speed things up. How many of you are using CloudFront or any other CDN in your cloud project? Do you know what a CDN is? How many of you have ever used Discord? Ever clicked on something that somebody put in a Discord channel, like a picture or a link or something? Go look at the URL sometime. They're all cdn.discord.com. They're literally Discord's content distribution network. Why would we put things in a special content distribution network? Why do we put things in a cache?
So that like others could use it, like multiple users can read from the same place.
Well, right. So certain things can be read from that cache, but the primary benefit is that it's faster. So you're right. It's multiple people can read it, but it's faster for the people who are reading it. So we spend the computational cost to figure it out once, and then we put it in a cache. But what happens if we have multiple caches? Could we? Where do we put the cache? And that's where it gets interesting. I already mentioned your web browser has caching. Lots of things get cached. But if you sit down and you watch a Netflix movie, I don't know, does anybody use Netflix? YouTube, pretty much any video service is going to do the same thing. What they will do is they will move the contents of that file so it's close to you. Literally, they will put it on a computer that is closer to where you are because it reduces latency, it improves the quality of your connection. And they have to move the data anyway, so they can move it even when their own network has greater jitter and put it close to you. So your use is smoother. And if other people are watching the same movie, they can also use that to show them as well. And this is essentially how we scale a lot of things in the cloud. We literally keep copies of them. The downside to caching is it doesn't work very well for things that are mutable. In other words, if it's a value that somebody's changing all the time, like what a time of day clock is a great example of that. You don't cache the time of day clock because if you get the one that was cached 5 seconds ago, it's wrong now. Now maybe you don't care about 5 seconds, but if you cache last Tuesdays and haven't updated it yet, well, it was right last Tuesday. That's not good enough. So caches have a different side effect, and that is that they can go stale. Timestamps are a really good example because when you see the time on a web page, normally it actually would have been computed at the time you fetch the page. It wouldn't have been cached. So logs should contain timestamps. They should contain what kind of error it was, how important was this, because frankly the 3 a.m.s only should be error. They shouldn't be warnings or infos or debugs. Not unless you figure out there's some special warning that presages a catastrophic failure, in which case you might want to turn that into an error too. But you have to have context. What was it involving? Where do I need to start looking? And a message. The more specific the message is, the better it is. And like I said, so you have an error message like the one that we showed earlier. It's going to have detailed information. When you're counting web services, when you're looking at what did they do, this is more about aggregate information. So this is like a temperature probe. How many requests per second are we actually performing? I've implemented systems like this before where you don't keep track necessarily of the immediate average, you keep track of a moving average. So you're looking for trends. You're not looking for, oh gee, we had a burst of 300 extra messages in the last second. So it's going to look like I've been really, really busy. Instead, it's over these time periods, I'm getting X number of messages per second. Error rates are important because that will tell you what percentage of calls are failing. When that number starts to get very high, then there's lots of things that can go wrong in this world because it's the internet. Packets get lost, things time out, and you want to be able to recover from those. But when that error rate starts to climb, that indicates it's not a transient error, it's something in your infrastructure. And it will only be as transient as it takes you to fix it. The latencies are really interesting. So a latency here is a measure of how many requests are satisfied within a certain amount of time. So a P50 is how many of my requests, how long is it before half of my requests have been answered? How long before 95% of my requests? How long before 99%? And as odd as it may sound, those numbers at the end there can often be much, much larger than the P50. And when you start tuning things, often what you tune for is what's called the tail latency, P99. Because somewhere in this range, between 95 and 99, is where most of the problems will start to manifest themselves. Things start to get slower, or there are transient issues that are bubbling up and are causing problems, but they don't make the average high enough to notice, but they do make the latency, the tail, long enough to notice. So here we go. If we had 50, 52, 48, 51, 49, 50, so you notice that everything except for the last one is pretty much right around 50. But if you take the average of those, it says, well, it's 545 milliseconds. You go, well, it's a little slow. It's a half a second. But here, that's somebody who waited 5 seconds. That indicates maybe there's something that's going wrong. That's the pain point. That's the customer you lose. This is why companies like Amazon actually care a lot about tail latencies. What can be really nice is you can actually build something with this level of observability in it. Now realize you can have a data format that's very compact and a tool that generates this for you when you start looking through it. As you do more logging and you do more, you collect more data, you will end up building these kinds of collapsing sorts of setups. So you can say, I have these requests, and maybe you get a one-line summary, and then you click on it, and what you get is a breakdown there that says, request ABC123 took 2 milliseconds to get to the API gateway probably from the load balancer. Took 15 milliseconds to do the auth step. Remember I told you it's stateless. We do the auth step every time we get a call. Then we spend database query, and there you go, 8,450 milliseconds. So that was 8.5 seconds for your database query. These are noise. That's your target. That was building in response. So the total was 8,470. So what, we've got 20 milliseconds for everything else and budget time for the database. Now, you talked about long, slow queries. The secret of queries are that if you have your database set up properly, they're blazingly fast. If you don't have your database set up properly, it will turn into a complete database scan. And a complete database scan could take minutes. It depends on the size of the database. In some of the research I did, I built a database that had about 32 million records in it. And I could tell just in how long it took the query whether or not I needed to go and look at the indexing state. Because if it had to do a database search, in other words, I had a field that I was trying to sort on or access, and it didn't actually have an index associated with it, it would take 3 minutes. If I had that index, it would take less than 10 milliseconds. Huge difference. Absolutely huge difference. If it's a once a month kind of query, you don't really care. Fine, let it take 3 minutes, that's okay. It's like a batch that you do once a month. If it's something that is in your forward-facing service, that's what you want to see. When you build a query, the database has a tool that will tell you what it's going to need to satisfy that query. You can actually use query planners to figure out what is causing the queries to be slow. So you can go and you can say, oh, I can see this step is causing a full database scan, so I need to go and I need to add an index. Now with SQL it can get a lot more complicated because you can end up doing things like with inner joins and temporary tables, and at some point you sit there and you say, I'm either the DB admin or I go find the DB admin. But then you find you're working for a company where they got rid of the DB admin because the DB was working fine for the last 2 years and they decided they could save that salary. I actually wasn't even making that up. I talked to somebody where literally they did that. And then the database broke. And they patched it together, and it falls apart in a couple months now. And nobody really understands everything that's going on in the database. But at least they know it's the database because you've got that observability layer. Even if you don't have tracing infrastructure, getting request IDs that can link things together across different logs. The request ID can just simply be a completely random value. UUIDs are very common because we have a large supply of UUIDs. They're cheap to generate. And they don't tell you anything. Because that's the other thing. They don't provide any useful labeling information. So no one else can look at that and realize that you're using that, or what it is, or what it represents. Here's the nice thing about good observability. It creates exactly the kinds of evidence that you often need to support your claims. So, building your observability means that you can actually say, look, it responds under 500 milliseconds. All I actually need to do is go through my latency logs and say, gee, look, it's below 500 milliseconds. P95. Now maybe I would make my CCT that it stays less than 500 milliseconds for P90 or P9090. Depends on exactly what I'm trying to promise. Handling off failures gracefully. Gee, showing me in your log here, handling them gracefully by saying access denied is perfectly reasonable. If you say under $50 a month, then you can use your metrics dashboard. You've got cost tracking inside of it. Well, here's what we're doing. Some people are using LLMs now. All the LLM services will tell you how many tokens you consumed, and you can use that to compute what the cost was. I use OpenRouter for a lot of the stuff that I do, and OpenRouter literally will tell you how much it cost you to like the nearest mill. So what is that? 100th of a cent? 0.0001. I've seen things that cost like 100th of a cent, and it's sort of like rounding error. It doesn't add up very fast. Unlike when you use Gemini 2.5 Pro. One of the Claude models likes to use that for something or other, and that's like 80% of my bill. Stop using that, it's expensive. Database failure recovery, you can actually use your logs. You can build tests that look through your logs and make sure that's not happening. Now you actually have a complete observability mechanism. You can automate this. You can literally say, let's run our tests on an hourly basis to make sure that we are obeying our own standards. We're claiming that we have good recoverability or whatever. So the question I'm going to ask you today is, when you look at your own code, your capstone, what are you doing for observability? Because I did talk about observability before. What are you doing for observability? Do you have log entries with timestamps? Are they well structured, or are they just random strings you put together? Structured data is a lot easier for us to deal with. You can deal with unstructured data, but it's a lot more work. Could you actually trace through and find a single user's flow through your system? If you needed to, if you were using that to debug a problem. Could you find all the requests that went to a particular endpoint? So these are different places where you might probe in order to understand the failure, to try and figure out what went wrong. In the end, ask yourself, if my cloud service was successful and something broke at 3 a.m., do I have the information I need from my observability data to identify where I need to look? And if the answer is no, then ask yourself what you should be putting there instead. So my suggestion is to take the learning prompt that I put on Canvas, and you can just literally say, teach me about application observability and monitoring. You can say cloud application. You can describe your application in more detail, although the learning prompt basically does the two-tiered approach. And I don't know if anybody used that yet or not. So you can say something generic like that, but then the LLM has explicitly been told to ask you exactly what you're looking for. And you can literally say, I'm building, and then describe what your capstone project is, or whatever your project is. And it will give you more detailed information. In terms of auditing your own code, you can actually use the AI to do that. Yesterday during office hours, I had somebody ask about their code. They were concerned about it. So I took their code and I literally gave it to Claude. And I told them, I said, this is the first step I would do, because anytime I approach a new code base, I go to the code base and I say, send out an agent and tell it to just look and report back what it finds. It's very specific. I'm asking for undirected search, not directed search. If you ask for it to give you something very specific like this is all you're going to get back. It's going to go looking for this. If you just simply say, hey, I found this new code base, I'm trying to figure it out, can you just go look and see what's interesting and report back? I literally say, report back. Tell me what you thought was interesting. Tell me what you explored. Tell me what you think should be explored that you didn't get a chance to do. And sometimes when the list that comes back of things that need more exploration, I'll just simply take that and feed it into the next one and say, great, now I have a map of what's there. Take that and go and look at the things that the previous one didn't. And you can build up a really interesting map of kind of a random code base that way. Or your own code base. I've used it on my own code base. I've literally said, okay, I've looked at this thing in 6 months, go through, tell me what's interesting here. I did that for my dissertation, actually. I went through and said, well, I think there were some things that got lost in the editing process, so can you please go through and find, and just go and look. Go and look and see what you find and report back. And in the end, I ended up with 17 different ideas that the AI agents looked at and said, these are publishable ideas. That was pretty interesting. I didn't say, go look for publishable ideas, because that would have created a prior where they would have wanted to give me a publishable idea. Instead, what I said was just go look and see what you could find. And then this morning, when I was doing 4.16, I used exactly the same example. I gave it live, and what did Claude do? Claude sent out 5 agents with explicit instructions on particular things to look for. And I got back a report, and it's really interesting, because the report is different than when I took, so then I said to Claude, I said, I asked you to do an unguided search. And it did. And you know what? It got a completely different response back. It was just completely, it was like night and day. So like when I'm looking at your code, the first thing I want is I just want something to go through and crawl it and say, what do you see? There's no prior there. It doesn't have a bias that says it's got to find good things or bad things. I mean, if you want, I could take your code and I could say, go and find everything wrong with this code. And it will make shit up. In the end, you will have a list of things that are wrong and you'll have a list of things that are not wrong. Or I could go in and say, oh, tell me every single good idea that's there, and it'll be the same problem. How many of you are using AI coding agents? Okay. When they write code, they are pattern matching. They are writing to fit patterns. If your code is trying to do something that does not fit their pattern, you will fight them every step of the way, because they will write the code that they are familiar with. They're not that different than humans, in all fairness, because that will happen with humans as well. They're really hard, and they're really good, and they're really fast, and so you don't notice that they actually wrote code that isn't what you asked for until you start using it and going, wait, this doesn't work. I said, we're writing a gateway, you gave me a proxy. Oh, well, it's too hard to do a gateway, because there's this problem. You could have told me about the problem instead of changing the project design. Oh, I'm sorry. Have you ever had one apologize to you? I don't believe them. I don't think they're sorry at all. And that's the point that I keep trying to get across, is that they are powerful tools and they can allow you to build things faster than you would be able to do on your own. But on the flip side, all they will build is what they know how to build. It is much harder to get them, and I've done it, but it's a lot of work to get them to build what you want. You literally have to build structural impediments for them to do it the way they want to do. I can't tell you how many times I've had secure databases that completely bypass the security wall. It took about 5 tries to get that one to work. It took me 4 tries on the gateway that I didn't want to be a proxy server. But it worked. I eventually got it. It was good enough. I posted a picture yesterday on X, believe it or not. I had Claude Code running through my gateway service, and inside the Claude Code, it literally said that it had 120% of all of the memory was used for messages. And the Anthropic API said it was 80%, and that included not just the messages, but also the systems prompt, which is about another 20%. So it was 1.7 to 1 difference. It was great. It was exactly what the project was supposed to do. It's supposed to demonstrate that by curating the memory, that curating Claude's memory, you could actually gain equivalent functionality using fewer tokens, which in turn means that the context window fills up slower and it works better. Well, I didn't claim it worked better. I said it was non-inferior, which is why easier to prove. Proving superior is a lot harder. But that was hard. It was difficult to get it to do that. And after I got that working, I asked for one more change, and it started trying to turn it into a proxy server again. I said, no, you cannot do that. Stop. Oh, I'm sorry. And it says that right here. Yes, it does say that right there, but it doesn't say. One of the things the AI industry won't tell you is they don't actually fully understand why these things work. And they definitely don't understand why these things work. Part of the research that I've been doing is looking at prompts and how prompts are interpreted by the transformer model. And the interesting part of that research is that it sure looks like the people who build the products based on those transformers at Google and OpenAI and Anthropic and whatnot, they don't really know what they're doing. They're kind of figuring out, hey, this sort of works. And the way that we were testing that earlier this morning, for me, was to run what's called an ablation study. And so in this particular case, we took the Cloud Code system prompt, and we broke it up into 27 different chunks. And then we removed different combinations of those chunks and measured how it changed Claude's adherence to the rules. And what we found just was like, you can take two sentences that don't appear to be connected in any sort of way because they're like about different things, remove one of them and the other one stops working. It's about 70% of the rules that are in the system prompt that appear to fall into that category. The rule itself isn't effective. It doesn't do anything, but removing it changes the way that a different rule functions. And you're like, wow. As far as I can tell, nobody's been doing this kind of a study before. Nobody's been saying, let's systematically do ablation. And part of the reason is that unless you go and spend the time to figure out how to do it effectively, a naive ablation of a system prompt that has 27 discrete pieces is 2 to the 27 different possible combinations. And that's not too bad. That's 128 million. So that's only 128 million calls to an LLM endpoint. How much could that possibly cost? How long could it possibly take? So, use them. They're actually very good at generating code, but don't value the code, because the value in using those tools is in you learning and understanding the strengths and weaknesses of the tools and how you identify and define the boundaries of the problem you're asking it to solve. The easiest thing to do is to ask it to write things that most anyone could write. The hardest thing to do is to get it to write things that most people haven't ever written. It doesn't have patterns in it. So it's working without a safety net. But if the worst is, if you want it to write something that is conceptually similar to something that's already been trained on, but you want it to do it differently, that's when it gets hard. I think I mentioned that one, where I have this specification for a named entity recognition project named entities, NER is what it's called. In NER, what we do is we try to identify different ways of describing the same entity. My phone. It also happens to have an IEMI. It also happens to have a serial number. It has a phone number attached to it. It's got a whole bunch of different identities. I have different identities, right? So, you know, the Canadian government has given me a number, and that's me as far as the Canadian government is concerned. But I have a name, and I have the name that is on my passport, which is different than the name that I normally use. And then we get into relational names. So if you tell your phone, call mom, it probably knows. But that's a different name again. So a named entity recognition database, which is commonly used in certain kinds of applications, is how you manage this complex web of relationships. One of the standard things to do in an NER system is if you come across a name identity map that you, for an entity you don't know, you throw it away. But you don't have to. You can actually keep it. And it has interesting advantages of keeping it, because it now means that when you find out who that entity is, you can actually attach prior information to it. But how do you get an LLM to write that code? You have to trick it. In that particular case, we wrote an entire spec using the language of Jabberwocky, which is a poem, a nonsense word poem. And by using terminology that was not pattern matchable, it actually worked. So I'm not saying that that's what you should do. I'm just simply saying that part of the skill set I'm trying to encourage you to build is understanding the strengths and weaknesses of the tools and how to use them effectively. So I know several of you, most of you have actually said you're using these tools. How many of you have had your AI generate bogus code? How did you know it was bogus?
It wasn't actually for this, but for a personal project. When I ran the project, it ended up like losing me some money. And so it turned out that I hadn't correctly wired up the ENV with the rest of the code, but it was all supposed to work.
So you learn.
Yeah.
Cost you money. You really learn.
Yeah.
Yeah, that's a good signal. When it starts costing you actually out of your pocket. And how did that change the way you use the AI in the future? Well, since then.
Try to give it more deliberate instruction, and then, I don't know, honestly just taking it a more careful look over everything, because like this was a really small code base, but it managed to make a mistake with even that. So paying a bit more attention and trying to be more deliberate with the instructions I give.
Right. And that's one of the reasons that I keep asking you to keep a log. How many of you have ever actually asked it a question, have it give you some answer that you know is wrong? You're not asking good questions then, or you're believing everything that it says. It will generate wrong answers. And let's see. Did I post that one? There's a Claudius Papyrus very recently about a paper. And the reason I noticed it was because the paper is applicable to something I've submitted. And I went and updated the paper to include the reference because it actually provides an explanation on why an AI will make up answers. And it's pretty cool because it has to do with what's in the training data and why it does that. Okay, so the training is not to give you a truthful answer. The training is to give you an answer that is essentially low entropy. So it's the least expensive path, or one of the least expensive paths through the completion space. And that often aligns with what's true. but that doesn't mean that it always does. One of the weaknesses, for example, I write papers. I can't trust any citation it generates. And a lot of that is because it's seen so many citations that it knows what they should look like, and it just simply generates them. Well, this is what it should look like. But it doesn't have any inherent knowledge there. It doesn't have a knowledge base that it's looking in. It's just simply creating a plausible completion. Let me check and see if I put that on Discord, because that was a really good one. And if it's not on Discord, where's Discord? Discord, somewhere here. There we go. How are the capstones going? 9 days, you think you're going to make it? Wait. Is there anything that I can do to assist in helping you be successful there? No, I didn't put it there. All right, let me go grab that link because I put it over here. There, I put the link to that. Why don't I give you the paper too, because the paper is interesting. No, is that the right one? No, that's the wrong one. I'll look up the paper at any rate. All right, well then I'm going to assume that you guys are in pretty good shape here. Let me move the mouse. I mean, it should be pretty straightforward if you feel like you actually want more observability or better observability than what you have. 30 minutes, you can have better observability than you have now. Just a quick list, down and dirty. All right. Just think of it as a brine of sugar and chocolate. Then I will see you on Tuesday. All right.